So, for example, I'll give you one example, this AI Feynman project
Yes.
that we just published, right? So we took the 100 most famous or complicated equations from one of my favorite physics textbooks. In fact, the one that got me into physics in the first place, the Feynman lectures on physics. And so you have a formula, maybe it has, what goes into the formula is 6 different variables, and then what comes out is 1. So then you can make like a giant Excel spreadsheet with 7 columns. You put in just random numbers for the 6 columns for those 6 input variables, and then you calculate with a formula the 7th column, the output. So maybe it's like the force equals, in the last column, some function of the other. And now the task is, okay, if I don't tell you what the formula was, can you figure that out from looking at my spreadsheet I gave you?
Yes.
This problem is called symbolic regression. If I tell you that the formula is what we call a linear formula, so it's just that the output is some sum of all the things inputted times some constants, that's a famous, easy problem we can solve. We do it all the time in science and engineering. But the general one, if it's more complicated functions with logarithms or cosines or other math, it's a very, very hard one and probably impossible to do fast in general, just because the number of formulas with n symbols just grows exponentially, just like the number of passwords you can make grow dramatically with length. But we had this idea that if you first have a neural network that can actually approximate the formula, you just trained it, even if you don't understand how it works, that can be the first step towards actually understanding how it works. So that's what we do first. And then we study that neural network now and put in all sorts of other data that wasn't in the original training data and use that to discover simplifying properties of the formula. And that lets us break it apart often into many simpler pieces in a kind of divide and conquer approach. So we were able to solve all of those 100 formulas, discover them automatically, plus a whole bunch of other ones. And it's actually kind of humbling to see that this code, which anyone who wants now who's listening to this can type pip install AI Feynman on their computer and run it. It can actually do what Johannes Kepler spent 4 years doing when he stared at Mars data until he's like, finally, eureka, this is an ellipse. This will do it automatically for you in 1 hour, right? Or Max Planck, he was looking at how much radiation comes out from at different wavelengths from a hot object and discovered the famous black body formula. This discovers it automatically. I'm actually excited about seeing if we can discover not just old formulas again, but new formulas that no one has seen before.
I do like this process of using kind of a neural network to find some basic insights and then dissecting the neural network to then gain the final. So that's in that way you've forcing the explainability issue. Really trying to analyze the neural network for the things it knows in order to come up with the final, beautiful, simple theory underlying the initial system that you were looking at.
I love that, and the reason I'm so optimistic that it can be generalized to so much more is because that's exactly what we do as human scientists. Think of Galileo, whom we mentioned, right? I bet when he was a little kid, if his dad threw him an apple, he would catch it. Why? Because he had a neural network in his brain that he had trained to predict the parabolic orbit of apples that are thrown under gravity. If you throw a tennis ball to a dog, it also has this same ability of deep learning to figure out how the ball is going to move and catch it. But Galileo went one step further when he got older. He went back and was like, wait a minute. I can write down a formula for this. Y equals x squared, a parabola. And he helped revolutionize physics as we know it, right?
So there was a basic neural network in there from childhood that captured like the experiences of observing different kinds of trajectories. And then he was able to go back in with another extra little neural network and analyze all those experiences and be like, wait a minute, there's a deeper rule here.
Exactly. He was able to distill out in symbolic form what that complicated black box neural network was doing, right? Not only did the formula he get ultimately become more accurate. And similarly, this is how Newton got Newton's laws, which is why Elon can send rockets to the space station now, right? So it's not only more accurate, but it's also simpler, much simpler. And it's so simple that we can actually describe it to our friends and each other, right? We've talked about it just in the context of physics now, but hey, isn't this what we're doing when we're talking to each other also? We go around with our neural networks, just like dogs and cats and chipmunks and blue jays, and we experience things in the world. But then we humans do this additional step on top of that, where we then distill out certain high-level knowledge that we've extracted from this in a way that we can communicate it to each other in a symbolic form, in English, in this case, right? So if we can do it, and we believe that we are information processing entities, then we should be able to make machine learning that does it also.